This video is on exponential growth with population, and we want to find the value of k first. Here's our example. The population P of Lincoln, Nebraska is P equals 224e raised to the kt, where t equals 0 represents the year 2000. So I'm going to go ahead and circle this first. When the time equals 0, that represents the year 2000. In 1980, the population was 172,000. So in 1980, the population was 172,000. And t is unknown at this point. And population is unknown at that point. So those are some things we're going to identify. And it says that this model, which is right here in the blue, is our equation, is in thousands. So really, this 224 represents 224,000. So we're going to go ahead and find the value of k. What is the population increase over time, the percentage of increase over time? So I'm going to go ahead and erase this question mark now and think about if my t equals 0, that's the year 2000. But I have to go backwards 20 years. So now my time is negative 20. And I want to just use the 172 because I have to remove the thousands place. So I'm just going to work with the 172 and the negative 20. And I'm going to plug it into this formula over here. So my population at the end in 1980 is 172,000. And then we have the 224. E, remember E represents 2.71. K is our unknown. And then our time is negative 20. And we want to solve this equation for k. So the first thing I'm going to do is I'm going to divide both sides by 224. And then E, and then k times negative 20 is negative 20k. Now I'm trying to, again, solve for k. So I want to bring that power and remove it. So I'm going to take the natural log of both sides. The reason why I want to do the natural log of both sides is a natural log and an exponential are inverses of each other. So what happens on this right-hand side, these are inverses, so I just left with this negative 20k. And then on the left, it's still just the same. The natural log of 172 divided by 224. Last step is divided by negative 20. So I have the k by itself. So I have the natural log of 172 divided by 224. And then it's all over negative 20. And now I'm left with the k left on the right. Now I take my calculator. Be very careful when you use your calculator. So I want to take the natural log of 172 divided by 224. Finish off that parentheses. What you get in the red is negative 0.26415. And then we want to divide that by negative 20. And we get k equaling 0.01320. That is our k. If we want it as a percentage, then we move it 2 places to the right. That is an increase of 1.3% per year. But we're going to leave this k as it is. Now we're going to use the result to predict the population in the year 2020. So remember, when time equals 0, that was the year 2000. Now we're at 2020. So now 20 years have gone by. So now my t equals 20. So I'm going to use that same formula up here in the blue. 224e raised to the kt, but now I can put the k in. So p equals 224e raised to the kt. And I'm going to take this k value and substitute it right there. So now my model looks like the population. We'll go to that many places, 4 decimal places is fine. And now we can go on and evaluate, predict any population after 2000 or even before 2000. So now we'll plug in 20 for t. So the population, 224 equals 0.0132, and we'll replace that time with 20. So with the orders operations, we do the exponent first, 0.0132 times 20. When you multiply those two values together in the exponent, you get 0.264. Now use your calculator. 224e raised to the 0.264, and you get p equaling 291.676. Now that doesn't really seem right because it says the population is now 291 people. If you remember, it's in thousands, so I'm going to push this back to the right 3 places. So the population in Lincoln, Nebraska in 2020 should be 291,676 people.